All right, so again, section 8.7, I think I told you 8.8 by accident earlier, but 8.7, L'Hopital's rule, has to deal with limits that require, or not that require, but that result in an indeterminate form. So let me explain, or at least give you the definition for that. So indeterminate form, meaning cannot be determined, right? I did not write that properly. Hold on. Indeterminate form. So when you take a limit of a function, not necessarily a fraction, but it can be, most of the stuff we're going to do is going to be fractions, okay? And your answer comes out to 0 over 0 or infinity over infinity. I don't know if you guys remember getting those solutions before. So those two, getting a 0 over 0, infinity over infinity. Usually what you'd have to do, if that were the case, you'd have to either calculate some values before and after your limit where you're approaching. So if you're approaching at 2, you might test like 1.999 and 2.001 and stuff like that to see if they're both going into the same direction. Maybe they're both meeting up at a certain value. Maybe they're going in opposite directions. So that's how we would check these things. We would just kind of calculate values and see, okay, what's happening at this number that creates this issue where I get 0 over 0 or infinity over infinity. Now, there are other ones, and I'll kind of change the color on these other ones that we're not going to do. Okay, so we're not going to do infinity minus infinity. We're not doing 0 times infinity, because I know 0 times anything is supposed to be 0, but when you don't know how big infinity is and how it behaves, what exactly happens when you multiply it by 0? Some people are going to say, well, it's 0. Well, we're not sure about that. Okay, so that's why it's called indeterminate. They've already tried to figure this out. 1 to the infinity, is it still 1? Right? We know 1 to any power should be 1, but what about to an infinite power? These are all theoretical questions. Or 0 to the 0. Like, is 0 to the 0 1? Right? We taught you guys that any value to the 0th power should be 1, but we never talked about 0 to the 0 power. Right? Like, what happens there? So these are all indeterminate forms. Okay, so when you're doing limits, these are things that could happen when you're like, okay, now what do I do? Okay, now for us, we want to only focus on these right here. Okay, for the AP exam, these are the only ones that they want you to worry about. Okay, 0 over 0 or infinity over infinity. And to be honest with you, for AB, you don't actually even have to know this whole lesson that I'm about to do, but I'm going to kind of just show this to you because it's a shortcut, okay, to having to do it the long way. Okay, so let me show you guys an example of this. All right, so, oh, actually, before I do this, let me write down L'Hopital's rule. So L'Hopital's rule states, if the limit as x approaches c, okay, of f of x over g of x is indeterminate, then use the limit as x approaches c of f prime of x over g prime of x. Now I want you guys to notice this is not saying to use the quotient rule. This is saying literally take a derivative of just the top and just the bottom. Okay? So you're going to take the derivative of the top by itself and the bottom by itself to see if you find a limit. Okay, if not, then apply the derivative again. Okay? So you apply it again, and if it doesn't work, then you apply it again. And if it doesn't work, then you apply it. And you keep doing this until eventually you find a numeric value. Or at least it's not 0 over 0. Maybe it goes to infinity. Okay, but you're going to keep applying it over and over again. So like I said, it's a pretty easy rule. You're going to take your limit first like you normally would. Hopefully it works. If it doesn't and you get 0 over 0 or infinity over infinity, then you apply this rule. You take the derivative of the top and of the bottom. At that point, you take the limit again, and if you get an answer, great. If you don't, you take another derivative. Okay, so here we go. Example number 1. So let's find the limit as x approaches 0 of e to the 2x minus 1 over x. Okay, so let's take that limit. All right, so when we go ahead and apply this limit, okay, when we go through and apply this limit, you're going to plug in a 0, right? That's what we do, direct substitution. So you end up with e to the 0 minus 1 over 0, which is 1 minus 1 over 0, which is 0 over 0, which is an indeterminate form. Okay, so we don't want that. So what I'm going to do is I'm going to apply L'Hopital's rule. But like I was going to show you guys, here's the graph, right? If we want to approach 0, let me make this into projector mode so it's a little thicker here. So if I want to go to 0, I just kind of get closer and closer to it. And you're going to notice once I get right at 0, it's undefined, right? Now, what should the limit be? What does it look like it's going to be? It looks like a 2, right? It looks like the limit should be 2. Before it, it's 1.9, right? Getting real close. After it, it's a little bit past 2. And the way you were supposed to do this before was that you're supposed to try plugging in, instead of 0, because it didn't work at 0, you would plug in like a negative 0.001, negative 0.0001, negative 0.00001, right? See how close it's going, and make a table. You guys remember doing that? Right? And then you'd go to the right side of the 0. So, you try 0.0001, 0.00001, right? Getting closer and closer to see where it's approaching. And that could take forever. So here's the deal. Instead of doing that, take the derivative of the top. What's the derivative of e to the 2x minus 1? Anybody remember? 2 what? 2 e to the 2x. And what's the derivative of x? It's 1. So basically this became the limit as x approaches 0 of 2e to the 2x. And now apply your limit again. So that means that this comes out to 2e to the 0, which is just 2. And we just saw that, right? On our graph, we saw that 2 was going to be its limit. From the left and right side, right? They're both approaching 2. So notice, instead of doing that big old table that I used to make you guys do, I knew that this was a shortcut. I didn't show it to you because I need you guys to figure out how to work this out in case all else fails. Okay, what else would you do? But this is L'Hopital's rule. So anytime you run into the problem where you're taking a limit and you get 0 over 0 or infinity over infinity, or any of the other indeterminate forms for that case, you take derivatives. Okay, you're going to take derivatives of the numerator, take a derivative of the denominator. So let's try another one. So we'll try e to the x, I'm sorry, example 2. I don't know why I said that out loud there. Example number 2, the limit as x approaches infinity of ln of x over x. So let me graph this one really quick for us. Okay, so ln of x over x. Turn this one off. Ln of x over x. And they say as x approaches infinity, right? So I mean that's kind of hard. I mean, it looks like it should be 0, right? It's getting closer and closer to the x-axis, and I'm sure if I zoom out, that's exactly what's going to look like. But if we don't know what the graph looks like, and we just, apply our direct substitution, we end up with ln of infinity over infinity, which is just infinity over infinity. Right? So that doesn't tell me anything. So I'm going to go ahead and apply L'Hopital's rule. So the limit as x approaches infinity of, what's the derivative of ln of x? 1 over x. What's the derivative of x? Well, it's a 1. So that means that this is basically the limit as x goes to infinity of 1 over x, which is equal to what? That's 0. Right? So in order to do this, if you didn't know how to do it and you couldn't graph it, you'd have to plug in numbers, right? And they have to be real big numbers. So you start maybe with maybe 10, maybe 100, then go to 1,000, try 100,000, try 1,000,000, and start seeing like where is this thing going, right? Making a table. But in our case, we can take a quick shortcut, and since it is one of those indeterminate forms, we can take a derivative. Now notice it has to be an indeterminate form. Just because you plug it in, you get 2 over infinity or something like that. Don't say, oh, that means I got to take derivatives of everything, right? It's only whenever you get these situations of 0 over 0 or infinity over infinity. Okay? And usually it works on the first time, but there are times when it doesn't work immediately. So let me show you one of those. So we're going to find the limit as x approaches infinity, negative infinity, I think, of x squared over e to the x. Let me just graph this for us here. So we're doing x squared over e to the x. So there's our function. So as we go to negative infinity, okay? So we're going, I forgot which way we were going, but yeah, negative infinity. So here we go. So you plug it in, and you get negative infinity squared, right? And that would be e to the negative infinity. And actually, right now I think about it, I should make this positive, because if not, I'm going to make this an infinity times infinity, which is probably not a good thing. So do me a favor. Let me switch this out. Let's make that infinity a positive infinity. Because or else I'm going to end up with a situation that we don't need to know how to deal with for the AP exams. Okay, so make it a positive infinity. All right, so when you plug it in, we get infinity squared over e to the infinity, which is infinity over infinity. Okay, so when we do that, let's go ahead and take our derivatives. Now, by the way, since I did change the direction, let's look at the graph really quick one more time. So we're going towards infinity, so we're going this way over here, okay? So it should be a 0, right? Whereas the other one was going to be a positive infinity, but this should be a 0. So now that we know that, let's go ahead and take our derivative. So limit as x approaches infinity of our derivative for x squared is 2x, and our derivative for e to the x is e to the x. And when we take that limit, we end up with infinity over infinity. Well, that's not good, right? So the rule says that you're going to take your derivative, top and your bottom, and bless you, take your limit again, and if it doesn't work, if you still end up with the same issue, do it again. So we're going to take a derivative of this again. So that would be limit as x approaches infinity The derivative of 2x is 2. The derivative of e to the x is e to the x. Okay, so what do we get for this? Well, it's 2 over infinity, so we get 0, which is what we should get. Now, if it didn't work at this point, then you do it again. All right, and you keep doing it until eventually you find a solution. Okay, so this is what you do instead of plugging in numbers. Okay, instead of making these tables and things like that, you're going to kind of apply this rule to make sure that you can find a solution without having to go through all that trouble. So right now I'm going to give you guys your homework for this, and you guys can work on it in class. All right, so here's the homework, guys. It's on page 576. Numbers 11 through 16, 29, and 30. Okay, so the assignment isn't too long, and hopefully it's not too difficult. So there you go.